I will use MPLAB to write assembly code, and there's have here 4 exercises. So before we do that, we need to go to see the specification sheet of the PIC we are going to use. Basically we will use B16F84A, so we can find it from the internet. We just type PIC 16F84A. Okay, so now this is the specification sheet for PIC 16F84A data sheet. There's many things you can find. The architecture of the PIC and some more details about the ports. This is the program memory where we have stack at the top, and we have a reset vector where we this is the starting address for the program. It begins at 0000, and at 004 there is a peripheral interrupt vector. It's where the interrupt address starts. So the program memory for the B16F84A ends up to the 3FF. The rest of the memory is not implemented. As for data memory, there is 2 banks, bank 0 and bank 1. The data memory is divided into 2 parts. The special function registers. Let me just zoom it a little bit. So the special function registers, it has the registers. There are different kinds of registers. For example, there is port A and port B, and it's corresponding that define the direction trace A and trace B. There is timer 0. There is one of the most important registers, status register, where there is flags can be defined. There is interrupt controller also registers. The other part of the data memory registers is the general purpose registers, where the user can define the variables. As you see that the B1684A, it has 2 banks, bank 0 and bank 1. So in order to read or write on one of the special function registers, you probably need to move from bank 0 to bank 1, or from bank 1 to bank 0. Some of the registers you don't need to move or to switch from banks, between banks, because they're already available in the 2 banks, like status register, like the BCL and the interrupt controller. Okay, so the data sheet contains a lot of information where it describes the registers in details and different kind of modules and features of the B16F84A. Okay, so let's begin with doing the exercises. So the first exercise is saying, like, we have 4 LEDs are connected to port B. From RB0 to RB3, using PIC83, use the MPLAB to write assembly program that light the LEDs. I already did this before in the previous video, but I want to do it again. So let's start doing it. So we have port B as an output, RB3 to RB0. Okay, so this is the MPLAB. So we need to create a project, standalone project. Next, now we can define the family. You can select it from here, or you can go direct to you select it from the big list. So B16F84A, we just go to the 16 yeah, F84 84A, B1684A. Yeah, this is the one. Okay, good. Next, so we use simulator. So wait, and we use the compiler is MPLAB. Let's type the name of the project. Let's call it exercise 1. Finish. So now we have a exercise 1 project. Now we need to create the assembly code, new assembly file.asm. We just can type exercise 1, and as you see that the format it's .asm, so you don't need to type it here. So just type finish. Good. So the first thing you need to do is to type include, to add the include file. So we type include P16 F84A.inc. Then let me just put the comment. So we need to display semicolon display the ports RB3 to RB0. Good. Just type this link. Okay. The first thing we need to do is to write the structure. So first we do the originate. ORG is where the program starts, and this is where it ends. Now we need to initialize our program. So we need to do bank select tris A or tris B, and then we need to define the direction of port B, since it's an output. So the tris B of a port B has to be all zeros. Clear F tris B. If you see that bank select, we move to bank 1 because tris A is in bank 1, and it doesn't matter whether it's going to be tris A or tris B. It doesn't matter because they are both in the same bank. And here with this instruction we clear port B, so all bits in port B will be zeros. Now we need to move get back to bank 0. So we're gonna type, we will say bank select port A or port B. Okay, so now we need to display RB3 to RB0. So we can do that by, can say move LW, where we move a literal value of type binary, and it will be 0 0 0 0 1 1 1 1. If you see that RB3 to RB0, they're all ones, and the rest is zeros. They're gonna be off. Okay, after moving the literal to W, we move it into move WF into port B, and that's it. It's all done. In order to make it continuous, we need to create a loop. So we can put it here, the loop, and go to loop. So we are done. So this is how it works. Let me just debug, build it, and see if it's gonna there is any problem. So the build is successful. Now we need to display the output, so we do that by either we can go to debugging and select variables. So we go variables. We can do it other way. We can go and say, for example, highlight recipe and say add new watch. It will appear here, recipe. We need to see port B also, new watch, port B. If we need to add another one, we can click here also. Let's say we need to see the W register. Okay, so this is how it goes. Now we can run the program. So if you see that the program is running right now, in order to we won't be able to see the output because it's keeping running. So the easiest, in order to be able to see the output, we click on debug and we pause it. So it's paused. Now we go to the reset, and once we click on reset, it will go to the next instruction after the ORG00. Okay, so the program stopped into bag select recipe. Now there's other things, as you see that we have hexadecimal, decimal and binary. Simply we can check anything we want. We can look for addresses or we can look for values. So let me make this close. Okay, so we have recipe, its initial input. Port B is 0, there doesn't display, nothing to display, and W register is 0. So when we can click F7, you see we move from one instruction to off, now the one instruction to another. So if you see clear F, recipe, now recipe will be 0. As you can see that recipe now it's 0, and port B is going to be input. Okay, so what's next? Let's click on F7. So now we move LW to W register. Now W register will be 1s, and it's keep going now. So you see that port B is 1 1 1 1 1. So RB3 to RB0 is going to be always on. So this is the program. Let me just close it, finish. So this is the first program. Let me go to the next exercise. What is the next exercise? Is write a program that repeatedly adds a number to W register. So it's very simple, very easy. We need to have any number that we can add it to the W register. We can create a new project. We create a new project. Next, let's select B16F. $84A. Okay, next. Simulator, next. The compiler is MPLAB, next. So we'll call it exercise 2. Finish. One thing you need to do now, before you write your code, you need to, since you have two projects, you need, and now we are working on project 2, you need to make this one as a mini project, because it's still focusing on this one, on exercise 1. So you need to make the second one is active. So you just simply and right click the project and say make, and sorry, it's already actually there. Let me see. Yeah, so if you would like to switch between a project, you can right click the project and you can set or unset as main project. So here right now, for example, project 1 is not being set, so if we set it, it will be focus on exercise 1. But for me now, I want to do it for exercise 2, set as main project. Now we right click on source file and type assembly. So now we close the source file. Let's call it exercise 2. Finish. We do the same thing, so include just put a comment here, add a number to W register. Okay, include B16 F84A.inc PORTB 00 and int. Okay, as you see that we don't need any kind of initialization, so basically we need to have add LW decimal. Let's add any number. Let's say we have number 10 decimal to the W register, and it's all done. Probably the easiest. Now we need to make it continuous, so we make a loop and we say go to loop. Okay, probably we need to clear W before we do the addition, so clear RLW, that's it. Clear W doesn't require any operands. So this is how the program. Okay, so let's build it. Successful, it's running. Now we need to display it, so we use the variables view. As you see, we don't have any trace B, so we can delete it, and port B will delete it. We have only W register. So let's run it now. Run the main program and pause it, then reset. So now we begin from the beginning. We check the variable. So we are here right now in the green. Let's click F7. So now W is 0. We add 10. Go to the low. We keep adding. So 10, 20, 30, 40, 50, 60, 70. So this is the program is so simple and so easy. Okay, so let's go to the next exercise. Write a program that repeatedly adds a number to W register and sends it to port B. Okay, so it's typically the same as exercise 2, but we need to, instead of keep adding it to the W, we need to display it into port B. So probably we can use the same program. We'll use the same program, we just need to modify it. So initially we need to go to bank, select clear F trace B. Okay, then we move to bank, select port B. So initially we define port B as an output by clearing trace B. Then we'll move to bank 0 again, and this will clear W. Then inside the loop we add 10 to the W register, and then we move it to WF to port B. Okay, so I guess it's done now. Just save it, debug it. So it's running now, there's no problems. Okay, now let's run it. So it's running right now. We do the same thing, just pause it and reset. You see the variable, we have W register. Now we have trace B, need to add it. We'll add it again, and then we have port B and watch. Okay, so we have 3 registers on the variables view. Let's click F7. Now trace B will be 0, and we probably need to clear also. Let's just stop it, because if you see that port B, the previous value of port B, it appears. Probably we need to clear port B before we do the addition, same as the clear W. So we can say clear F port B. Okay, alright. Let's run it and pause, reset. Pick the variables view, then F7. Now W register has been, trace B has been cleared. Now W register was cleared, port B should be cleared. Now we do the addition. So we added W10, then it will go to the port B, then at 20 it will go to the port B, as you see. So this is how it goes. You see that every time you add 10 to the W register, then it moves to the port B. It's a very simple program. Alright, so let's do the last exercise. The last exercise says there are 2 switches, so basically we have 2 inputs and they are connected to port A, and their LEDs are connected to port B. So we have 2 switches at RA4 and RA3, and the LEDs are connected to port B regardless of how many LEDs. Write a program that moves push button switches values from port A to LEDs in port B. It's simply, we just switch on, turn the switch on and off on port A, and it will light the LEDs in port B. Okay, so let's get back to the MPLAB for a new project, standalone project. Next, select 84 16F 84A. Okay, 7784 should be here somewhere. 16F, no, 16F should be somewhere there. Should go down. Yeah, should be somewhere. Okay, this is the one. Next, simulator. Next, let's call it exercise 4. Probably this already exists. Let's call it 40. Okay, finish. So we have the exercise 40, and we check if it's been, yeah, it's the main program. New simplify Excel for. Okay, so we have here RA4 as an input and port B is an output. Okay, the same way we do it with the previous programs. First thing we need to do is to include the PIC, include file 16f84a.inc. Second thing, we need to write org00, then end. So this is how the structure in all PIC assembly code. You write the include at the top, you put the org00 and end at the bottom. So first thing we need to do is to initialize our ports. So we need port A to be as an input. First of all, we need to go to bank 1, bank, select port A. Then what do we need to do is to make port A as an input. So we can say move LW binary. We can put them all once like this. 6, 7, 8. We can do them this way, but since we are, and this is fine, but since we want to do that, we have only inputs as RA4 and RA3, we can make them this way. So this is 7, 6, 5, 4, 3, 2, 1, 0. So the zeros mean that they are output, and the ones that mean they are input. It doesn't matter, by the way, but let's just follow up the exercise. So after we move it to the W, now we have to move it to WF trace. For port B, the easiest way is to write clear B. Okay, alright. Now we need to bank, select port A, and I find also probably it's easy, it's better to clear both. Clear F port A and clear F port B, just to make sure that they are zeros. Okay, now we need to read from port B, port A. So let's say move AF port A W. This will means that the what's available in port B, put it in the destination W. Then after we put the values, the value of port A into W, the input, we go and say move WF into port B. So it's all done. It's simply we move it from first, from, let's put here port A into W, and the other instruction is W to port B. Alright, and as usual we need to have a loop so that we keep it going. it's all done. Okay, so let's just build it and see if there is any bugs. Okay, looks good. Now we have variables which basically shows the output, but we need to have another views where we can inject the input signal. So if we go to Windows debugging, we go to simulator, there is stimulus. The stimulus, it allows you to define the input ports and inject the signal within your PIC while you are simulating. Okay, so what do we have? We have port RA4 and RA3, they are input, so we can select them from here. So RA4 should be let's make it RA3 first, and we can add another one, RA4. So we have two switches or two input, and right now they are both high, and this is here this is where we can inject. We click on the arrow where we can inject the value as high. So we have the input here and the variables, we can see the output. Let me just make it more clear. Let's delete all, and let's begin with port B as an output. Or let's start from here. So initially we have trace A, okay, then a trace B, watch, okay, and then port A, you watch, and port B. I don't want to show the W register right now, so I'm good with only with these ports, trace A, trace B, port A, and port B. Now we can run it and go to the pause, then reset to start from the beginning. So we are starting from the next instruction after the ORG00. Okay, so let me go to the stimulus. So initially we have two RA3 and RA4, they are all high. Now go to the variables and let's click on F7. Now we have trace A will why trace A didn't show. Okay, so there is something problem. Yeah, okay, I got it. Here we need to make it trace A, not port A, because when we select port A, that means we are in bank 0. We need to make it in bank 1. Okay, so let me just close it again and build it. Then pause, reset, go to the stimulus, inject high, and we go to the variables. Now we move line by line. So now trace A has to be, you see that port RA3 and RA4 become input, and port B has to be now, trace B has to be all zeros. 7. Okay, there's now zeros. Now we go to bank 0. Now we clear port A and port B. Now they are both cleared. Then port A now we have too high. As we see that RA3 and RA4, they are high right there. Now it should be, we should move it to W. me just click here, W. Now port B has to be same thing. You see that port B now are RB3 and RB4, they are now high. Okay, so if you keep clicking, it will be always done. Now I can change the stimulus. Let's say I put this low, RA3 and RA4, keep it high. Now what I would see in the variables is something like that. So see, RA3 now 0 and RB3 should be 0. See from there. We try it again and make them both low. Inject and go to the variables. F7 now both zeros, they both they turn off. Okay, so these are the exercises and that's for today. We just turn it off. Thank you very much.